this talk is about news from the Corpus Workbench. I will have the first part where I will talk about how I embed the Corpus Workbench in a Corpus linguist's workflow. And in the second part, Professor Ebert will talk about finite state queries. What are the methods of corpus linguistics that we're using? A corpus, of course, is a collection of texts. And what corpus linguists are usually interested in is, firstly, well, broadly speaking, three things. Firstly, finding actual text spans for close reading. Well, writing a corpus query and then looking at the concordances. To summarize the query results, which is some kind of distant reading, for example, looking at the frequency breakdown of actual query matches, possibly restricted to some anchor points, like specific points in the query matches, or to inspect the distribution of the query matches across metadata, wherever this is applicable. And lastly, two of the main methods of corpus linguistics, of course, is collocation analysis and keyword analysis, which is basically a summary of the contexts or the whole texts. Well, the IMS Open Corpus Workbench, I guess everybody knows it, provides the corpus linguist with tools for managing and querying large corpora with linguistic annotation. And the central component is the corpus query processor, which, yields the matches to the queries formulated in the corpus query language. There's a corpus query language tutorial online for those of you who are not familiar with the corpus query language. And well, this CQP enables mighty searches because it supports basically regular expressions over two layers, once over the characters to match word forms and linguistic annotation, and over tokens to match lexicogrammatical patterns. Additionally, the CWB ships with tools for encoding, indexing, decoding, and frequency distributions, and is used as a backend by software such as CQP Web. I think Andrew is also here. The de facto standard as a general purpose corpus linguistics toolkit. Polmine R, a recent implementation in R, and CWB CCC, the package that I will present today, which is a Python-based implementation. Short history of the Corpus Workbench. The latest release of the Corpus Workbench, the latest official release is 3.0, I think from 2010. I think this week there was a question on the mailing list: is the Corpus Workbench still being developed? And the answer, of course, is yes. Just because this is the latest stable release doesn't mean it's not still being developed. Andrew and Stefan have been working on various features since 2010. And the branch that is recommended to use is the version which we are using is 3.4. This is being developed continuously. Well, how do you get the Corpus Workbench? Well, you should check out the trunk of the Subversion repository to get the latest version of 3.4. Installation is quite easy on Linux and macOS. I will not talk about Windows. And there's detailed documentation available, spread across two tutorials. One is more directed for the actual user, the CQP tutorial, the people who are querying the corpora, and the encoding tutorial obviously is for the people who are encoding the corpora. If you have any questions to the Corpus Workbench, today is a good day to ask questions to Stefan. And the developers can be reached on the official mailing list. This is a very active mailing list. So the data model that the Corpus Workbench is using is basically there's two things that you have to consider. First of all, it is using verticalized text, meaning it assumes that there's tokenized text. Each line is one token. Each token has a corpus position, and each token can have several annotation layers, the so-called positional attributes or P attributes. The first layer, the primary layer, is the word layer, and further layers can be, for example, pos tags or a lemma or pronunciation or whatever you're interested in. Furthermore, there's structural attributes that can be indexed. These comprise several token spans, usually one or several tokens, and encode, well, structural information, for example, the length of the whole text, or sentences, or the values of these annotations. For example, a text can have categorization into a language or genre or a register or whatever. Maybe a quick example for those who are not so familiar with it. This is the input format of the Corpus Workbench, and you can see here, these are the structural attributes encoded in XML tags, and here are the positional attributes in verticalized text. So verticalized text you read from the top to the bottom. So this first tweet in this case would read some username, then, well, you won't win and you know why. The Corpus Workbench, as I said in the beginning, is used to convert, it ships with tools for converting the verticalized text into a binary format, and then tools for indexing and compressing these attributes. As a result, you have a corpus and you can access it. What I normally do after indexing a corpus is to use CWB describe corpus, a command line tool, to check that the indexing was successful. And this is a typical result of a corpus description. It tells you which attributes are encoded, and here's also a size in tokens. Yeah, so what can the Corpus Workbench, what does the Corpus Workbench offer for the actual corpus linguists workflow? Well, first of all, you can use, for example, CWB LexDecode for creating frequency lists, or CWB scan corpus for subcorpora. And then, of course, the main component is the corpus query processor, which you start. Then you can look at the corpora that you have. You can activate a corpus that you're interested in. You can see the attributes that are annotated. And then the main work of the corpus linguist is, of course, to write queries, to inspect or to export the results of the query, and to interpret the matches. This is a bit inconvenient to work on the command line, and that's why there are programs such as CQP Web, which offer additional, which offer nicely formatted query results, and also additional quantitative tools for quantitative analysis. The CWB CCC module is aimed at corpus linguists using Python, or at least familiar with scripting a little bit. It offers, it basically extends the functionality of the Corpus Workbench. For example, it gives you the possibility to have nice formatting, and the results are automatically cached. The main advantage of this interface is, however, that you can directly access the query results as data frames in Python pandas, and do your own quantitative analyses that you're interested in. It also ships directly with a couple of useful methods for quantitative analysis, for example, collocation analysis, keyword analysis, and summaries of anchor positions. Yeah, this second part of the first part of the talk is now a practical session. You could just install the Python package using, for example, pip. The module lives in PI, I think, is the preferred pronunciation. So in the Python packaging index, or you can just check out the GitHub repository and install it from scratch. If you look at the GitHub repository, there's also a Markdown document, this one that I just uploaded, and this I will present in the remainder time. So either you open the RMD or the HTML file. For those of you who are familiar with Python and R, they see directly this is an R Markdown, and yes, this is not a mistake. This is actually the way I did it. I used an R Markdown document in which a Python interpreter is running because I like R for visualization purposes. However, if you're not familiar with R, you can just follow the Python snippets and see and then use Python yourself for visualization or data analysis or whatever. Okay, so if you download the script or if you just follow my screen, this is the knitted R Markdown document. I will not use any fancy extra libraries except all those in the tidyverse universe and cable extra for the R Markdown and for the Python interaction, so that this is actually running in the R Markdown. I use the package Reticulate, which basically manages the Python process. If you installed the CWB CCC beforehand sometime, it might be reasonable to update it. As of today, the newest version is 0.913. I think I uploaded it around 1 o'clock in the afternoon. Yes, so as I said, in this R Markdown, I'm just running Python snippets. Here, this is just Python and R Markdown. I can just use Python the way I use Python in any other interpreter. I import the module as CCC, and I can see this is my version. The starting point of any analysis is probably to look at what corpora are installed or what corpora you have access to on your machine. This you can do it with importing the corpora class and using the show method. For each corpus that these are my system corpora, obviously, for each corpus which is accessible for you, it displays the name and the number of tokens. If you have any problems with getting this, started with this, probably then either your CQP is not in your path. The implementation assumes that the CQP is just accessible via the command line, or the registry path is not in the usual directory. That means somewhere at user local share. So you can use those parameters to point to the to CQP and your registry. So if you want to do some analysis, you start with importing the corpus class and initializing a corpus by naming it. As a result, you can see these. You get a small feedback that this is the corpus that you have initialized. I'm using the Brexit. A Brexit corpus is a corpus of tweets. There are tweets about the Brexit from 2016 between May and June, April and June, I think. 32 million tokens. Here, if you don't set any special data directory, you can it will point somewhere to temp in your temporary folder. As a small feedback, you also get the annotated attributes, and you can have this is convenient so that you know how your attributes are actually named. So there's a distinction between the positional attributes that are annotated. So here we have the word layer, of course, and the lemma layer, and 3 different kinds of pos tags. We will just use the pos arc, which is a very simple pos annotation. And there's a lot of structural attributes. All those structural attributes from the tweet level, like the tweet ID, the language the tweet was posted in, this should be English in this demo, the timestamp, the user ID, the screen name, and so on and so forth. And there's also some linguistic information, structural attributes with, for example, noun phrases and verb phrases. So as you can see, this is still Python. If I look at this at the attributes, for example, I see this is a data frame. This is a pandas data frame. I can access this data frame from within R in this R Markdown using pi, then a $sign, and then the name of the variable. And in R, of course, this pandas data frame is a simple data frame, and it looks like this, nicely knitted into this R Markdown. Okay, so let's do some actual corpus linguistics, I'd say. So I have a couple of example queries, but they're mostly very boring, but they should show what are the concepts and how to use the methods and the classes. The first thing I'm doing here is I just query the whole corpus for the lemma harm, and I can see what matches I actually get by looking at the breakdown. The most common one, of course, is harm itself. Then we have one with capital letter. We have all the inflections when it is used as a verb and so on. The matches object is actually a special object with lots of methods, and they basically are all based on the dump, the CQP dump of the query matches. The CQP dump consists of 4 columns. In the Corpus Workbench, these 4 columns are basically match, and anchor and target. Match, and anchor and target are just corpus positions of the respective matches. For example, match and are here always the same because the match is a single word or a single token query. So wherever it matches harm, every result there's match and is the actual corpus position of the token where the lemma is harm. The context and context end, well, this is basically a legacy of an early implementation, but it gives you 20 words to the left and 20 words to the right, and you can access, or you can use parameters to say how much context you want to have. The query result is being cached, so once you set the context, the complete data frame together with the context is being cached, so you can access it later on. This is reasonable not only for caching purposes, but also sometimes if you have queries that span over several tokens, you probably want them to be within one sentence or within one tweet or within one text or paragraph or whatever. You can, of course, include this in your CQP query. Here it would be lemma equals harm within tweet. If you define it via this method, also the context will be limited to this area. Okay, so this is basically the pandas data frame that all the methods are working on. And the first thing that you're probably interested in is concordancing. That means to look at the query matches in context. And this is achieved by the concordance method of the matches object. In R, this looks like this. Okay, we have as a result the context ID, the context in the context, and actually match and is the multi-index of this data frame, which is not shown in R, but we will not need it here anyway. Every entry in the raw column is the actual concordance, and the actual concordance is a list of lists where several pieces of information are encoded. The most important one is, of course, the word layer. It tells you the actual words of the query match in context. So the whole context is the tweet, and here are the words. So the first match here was EU warns Israel policy of demolishing Palestinian homes in Area C will harm relations. So here's the harm, and this is the context. This word list is aligned with several other lists. The CPOS list, of course, gives you the corpus positions of the words. So the actual the indexing ID, if you want to, and the offset tells you how far are the tokens away from the matches. And there's several other pieces of information about the anchors. In this case, we only had match and match end, as well as context and context end, but there can be more information as we will see later on. Of course, this is not really convenient. So there's a function implemented which just formats this as a table where you can read the actual text. The format is called simple. And then you get for every line, for every match, a line in your data frame where the actual text is written. So this is the actual text. Most often people are interested in a quick format. That means keyword in context. So to look at the match in context with left and right context, you can use this form is equals quick in the concordance method. So you get the left context, the node or the actual match, and the right context as separate columns. So since this is an R Markdown, I'm just using a little bit of R post-processing to have a nice table of the matches, which looks like this. These are just a couple of formatting instructions to have a nice table in this R Markdown. Of course, you can use any kind of other scripting language to post-process the results. So far, we haven't won anything much because the Corpus Workbench or the command line interface of the Corpus Workbench offers basically the same things. What I always found a little bit awkward when looking at results in the Corpus Workbench in the command line was the presentation when I want to access several attributes. For example, I not only want to know where are the matches and what is the context of the match, but I also want to know, for example, who wrote the tweet where this match is in. So show me also the screen name of the tweet, which is a value of the tweet annotation. Or I also want, besides the primary layer, I also want to see lemmata, but not only lemmas, but also the word layer. So this is basically a line text that I want to have displayed. So there's two things. Firstly, the structural attributes that you might want to retrieve, and secondly, the positional attributes that you want to retrieve. Let's start with the structural attributes. This is part of the concordance method. You can just say as show. So show me structural attributes. For example, the tweet ID and the tweet screen name. These are both structural attributes which are annotated in the corpus. This is the result. It looks a bit like above, but additionally to the text here, we have simple output formatting. Additionally to the text, we have columns tweet ID and tweet screen name, which gives you to each match the corresponding values of the tweet annotation. And then you can, of course, do some quantitative analysis of the results. For positional attributes, it's if you look at the Corpus Workbench, there's the possibility to display several positional attributes, and they are separated by a slash. I think is the standard, is the default, which makes it very hard to read. Here, the concordances in CWB CCC also offer the possibility to show additional positional attributes. Here, I'm opting for word, lemma, and one of the post tags. The result of such a concordance looks a bit like the above, with the difference being that now I have a named list of 5 items here in the raw column. Before that, it were now it's 7. Before that, it was 5. And obviously, the additional positional attributes are just aligned lists with the primary layer. So you can see here, this is the word layer. Additionally, we have the lemma layer and this post arc layer. And all these layers are obviously aligned with the offset and the CPOS, the corpus position. This formatting is, of course, also a bit inconvenient. The problem is, how do I get this into a flat data frame? Well, there's no straightforward way of doing this. If you have several positional attributes that you want to show, that's why the simple format is not implemented. What I'm usually doing is I'm opting for an output format of data frames. So each match in this case is the result of each match is a data frame. And so if I look at the first result, this is a bit awkward because Python starts counting at 0 and Arc starts counting at 1. But yeah, so this is the first result of the concordance. So if I look in this column DF, where the data frames are being saved, the first result looks like this. The first result is itself a data frame where I have basically verticalized text that I can inspect again. So here's the word layer, and we have the lemma layer in addition, and the POS layer. There's also a couple of more columns which indicate the match and the match end. For example, here the match was at harm, so this is match, and of course also match end. Context and context end is the first, only the first and the last token of the result have this. Okay, so this is interesting for corpus linguists who are interested in, for example, updating their query. When you're writing queries and want to have high precision, then you probably want to inspect all the results and see why your query matched wrong results, and how to maybe also improve recall by relaxing some of the query constraints. So you can look at the actual query results in context with additional attributes being shown. So which concordance lines are actually being shown? There's basically 2 parameters that influence which concordance lines are being shown. One of them is the cutoff parameter, and the other one is the order parameter. The cutoff parameter tells you how many concordance lines, or you tell the program how many concordance lines you want to have. And the order, well, is either first, last, or random. This is just directly passed to the Corpus Workbench, which gives you either the first, the last, or a random amount, a random sample of concordance lines. If you want to export, much of corpus linguistics that we are doing here is actually being combined with manual annotation of query matches or of certain text spans of the corpus, you probably want to export the query matches. And obviously, the simple or the quick formatting is perfectly suited for this because these formats are flat data frames. Like here, you have flat data frames where each column is something of interest. Probably the quick format might be problematic with Excel or with other programs. So you can use quick or simple for exporting. If you work directly in Python, you can just use the method of the pandas data frame. If you work from within R, you can, for example, use the write tsv method from the tidyverse. This was basically a quick summary of the functionality of the qualitative methods that the module provides, and now I'm going into quantitative analyses. The first thing that we're looking at is some metadata analysis. What I mean by this is that you might, for example, be interested in the distribution of your query matches across metadata. For example, the relative frequency of query matches across months or weeks in this case. Yes, in this case, I'm looking at weeks. So what I have here is I'm just having a separate program or a separate data frame with metadata. Here I'm just looking at the ID and the day the tweet was being posted. This is actually encoded in the Corpus Workbench, but here I'm using it from a separate data frame. I find it way more convenient to use just standard spreadsheets, tables, and R data frames to work with metadata, and then to combine it later on with matches from the Corpus Workbench. So how do I do this? Well, this is the metadata. It looks a bit like this. We have the ID of each tweet, and this ID, of course, also has to be annotated in the corpus, which is indexed by the Corpus Workbench. Otherwise, this whole procedure does not work. And for each ID here, I have a date. And what I'm looking at here is the matches of the query of the lemma vote. So mostly this is the word vote, but also, of course, the inflections and so on and so forth. If I now look at the actual concordance of the matches, I just have to make sure that I retrieve the tweet ID with the concordance lines. Then I can directly feed them back into R and count them in there. So here I have, I just created a data frame of the number of hits per tweet for all tweet IDs. And I joined this to the complete data frame of my metadata. So this is my metadata, and I have a data frame of counts that I just created here, and I joined them together. And with a little bit of tidyverse magic, we can just visualize the results from within R. But as I said in the beginning, you can, of course, also just use, I don't know, pandas or matplotlib in Python. Okay, so this way you can actually include metadata reasonably in your analysis. A further possibility are anchored queries. Actually, since the Corpus Workbench version 3.4.16, I think, the CQP allows setting several anchor points in the query. So, for example, to directly specify the head of the query, or certain parts that you are interested in your query result. Of course, this only makes sense if you have a query across several tokens. Here I'm using a library with macros and word lists. So word lists are just text files with one word per line, and macros are macro definitions as specified in the CQP tutorial. I'm not using macros here. It's just if you use a library with this module, then probably you're interested in macros and word lists. So you need to have a folder which contains macros and word lists. Here I'm using word lists created by Natalie, which is also in the audience. And I'm using it for a so-called argument query. This is the query. It's relatively complex. This query is supposed to extract arguments of the form, some entity says that something harms something. And it works like this. We have basically the two anchor points which confine the region where the entity is, two anchor points which confine the region where well, I called this later wrecker, and this is the wreckee. So the one who wrecks or harms, and the one or the thing that is being harmed. So 2 to 3 is the wrecker, and 4 to 5 is the wreckee. And we are using some word lists in here to limit our results. So if you query this, sometimes you run into the problem that setting these anchor points is not sufficient, because you know where to set the anchor point, but actually you want to have it, you want the anchor to be one before or one after the actual match here. So what the module allows is to correct the anchor points by certain offsets, just negative or positive integers. Well, here we're passing also match strategy equals longest to the Corpus Workbench to actually match the longest, find the longest matches of this query. If we are looking at the breakdown of the matches, this is of course well, this is interesting. However, this is not the best summary of the query results that we can have, because we are actually not interested in the breakdown of the matches, so a breakdown of the actual query results. We are probably more interested in the entity and the wrecker and the wreckee, or the one who harms and the one who is being harmed, which are conveniently defined by the anchor points by Natalie. If you now want to have an automatic summary of these anchor points, we have to define which anchor points we are interested in. So as I said in the beginning, we're interested in the following regions: from 0 to 1 for the entity, from 2 to 3 for the wrecker, and from 4 to 5 for the wreckee. And this is what I'm doing here. This is when I'm retrieving the concordance, I'm telling the module, well, I want to have the following slots. I want to have the entity, it goes from anchor point 0 to 1. I want to have the wrecker, which goes from 2 to 3, and the wreckee, which goes from 4 to 5. To get a direct summary, I set here the form parameter on extended. What does one match look like? Well, again, this is a data frame. Sorry, this is the complete data frame of the matches. Now we have several anchor points in addition to match and match end, and context and context end, and the text. And for each query match, we directly get what was defined between those anchor points 1 and 2, 2 and 3, and 4 and 5. Each actual match, of course, has the same information. So one match now looks like this. We have the word layer. It goes until here. And here we have the anchor points. This was not on purpose, but funnily enough, this is the same tweet that we had matched before. So what we now can get directly, and what we are probably interested in, is a summary of the frequency distribution of the slots that we defined above. So what's in the slots? I just look at the entity lemma. Lemma is the p attribute that I requested for this slot via the p slot attribute, and I can get a frequency distribution of who says that what hurts what. Here, for example, the first hit for the entity is economist, so probably these are economists who are saying something, and then we have the wrecker, so who is wrecking something? Well, this is a corpus about Brexit tweets, so it's Brexit. Who is wrecking something, who is harming someone, or the EU, or Britain, and so on and so forth. And what is being wrecked, what is being harmed? Well, this is the economy, a broad table, okay. So 24 times the economy itself without the article 12 times, and so on and so forth. This is something that the Corpus Workbench itself does not directly allow for, because the Corpus Workbench actually only allows two anchors to be set to be active at the same time. So if you want to use several anchor points in the Corpus Workbench, you will have to have a wrapper script running and collecting the results. And this is exactly what CWB CCC does. Okay, I can see we are a bit over time already, but I do want to talk about collocates and keywords, so I'll make it quick. Firstly, well, long story short, the module calculates collocates and keywords correctly, considering the breaks and the regions. So these are window-based collocates in this case. It works like this. So if, for example, if you look at the word harm and set the context break to tweet, it will count all the words around harm in tweets and will break the context at the tweet end. This just works with the collocates method. By default, the collocates method is set so that it will retrieve collocates for a window of 5, and it will order the collocates according to its frequency with a cutoff of 100. This is not unbelievably unreasonable, but it's also not the best setting, of course. The best setting is that you beforehand already know what kind of association measure you want to use, and you will have to sort the matches, the collocates according to this association measure. I think I saw Parkus Omolka in the audience. He implemented the association measures package, which implementation of some association measures that are quite frequent. So the module uses this association measures package in the background to score the co-occurrence counts. So here we have the collocates of harm sorted by absolute frequency. And as I said, this is not very reasonable because, of course, the most frequent item in this corpus is Brexit, and this will for sure pop up for most any of the corpus queries. And I do apologize for this decimal comma. I thought I set it to full stop, but it doesn't seem to have worked. Okay, so long story short, the collocates method returns collocates. You can sort them by a couple of by one of these association measures, or you can also just retrieve all the collocates and score them yourselves. You can just use the columns 011, 012, 021, 022, which I call the contingency notation, because it's just a contingency table, which is provided here. In the association measures package also directly gives you the expected frequencies. So these are the observed frequencies. These are the expected frequency. It also yields a different namespace for the columns, the so-called frequency signature, which was introduced by Evert 2004, I think. Yeah, you can also query other annotation layers. By standard, by default, it will query the lemma layer if this layer is a attribute which is being indexed in the corpus. Otherwise, it will fall back to the word layer. As I said, there are a couple of parameters that you can use to select which collocates you want to see. Same goes for keywords. For me, the natural way of defining subcorpora is via spreadsheets, as I said in the beginning. That means I will usually look at the metadata, restrict it to use it to define a subcorpus via the text IDs or the tweet IDs. In this case, so here, for example, I can look at all the tweet IDs from May, and here I have all the tweet IDs from June. And then I would just tell the module to give me keywords for the subcorpora which are defined via these IDs. This may be a bit awkward a name for the method, but it does the job. And the result, of course, are the keywords. Here we are back in R. I'm just formatting the keywords as a table sorted by log likelihood. Yeah, and I also display log ratio. So for May, for example, in our corpus, the keywords are the Eurovision, something about the G7, I guess, the summit, Brexit, the movie apparently seemed to be trending. Okay, the IMF, and so on and so forth. And for June, there was a TV debate, I think, and Joe Cox's murder was prominent in June. It makes sense. These are highly frequent, of course, because log likelihood, because this is sorted by log likelihood, and log likelihood prefers the ones which are very frequent. And here, just as a gimmick, in the end, I did some small visualization. I implemented a small visualization function in R, which basically displays collocates or keywords using three different measures. One for the amplitude, for visualizing the amplitude, one for the significance, which is color-coded, and the size, which uses here the marginal frequency. So, for example, the collocates, what do we have here? The collocates of harm, it was above sorted by log ratio, which is, of course, Andrew Hardy's definition of log ratio. So we have crime fighting, upstream, I don't even know what this is. Britain, EU, okay. So these are the collocates for a window size of 5, nicely visualized, and these are also window size of 5, but now log likelihood. As you can see, those are all significant because typically The top collocates according to log ratio are also well, if you have a cutoff of 1 or so, then the top collocates, if they have a log ratio of 10, they must at least they must occur 100 times in the corpus, I think. Yeah. Maybe more interesting, it's more interesting when you look a bit more in the middle of the corpus. For example, here, these are the collocates ranks 480 to 500 or so, sorted by log ratio. You can see there are a couple of them which are significant, but most of them are not significant. That's what this color code implies. Okay. I am very happy if you are using the module. You can create issues in the GitHub repository if you're interested. There are a couple of issues open. Most of them I opened today when I was thinking about where does this code lead me. I'm still not in version 1.0, so most of those issues will be fixed in the next couple of months, I hope, whilst working on version 1.0. Okay.